something that. Okay, so tonight we're going to be talking about networking guide to networks, uh, address, addressing on networks. Chapter 3 in the book. So a couple of things in chapter 3 we're going to go over is the MAC address. Looking at the MAC address, explaining the different MAC address. You guys probably heard that term several times before. But the book also touches on TCP IP protocol. It's going to lightly address it how it applies to the OSI model. So pay close attention to that. And then it's going to talk about the different sockets and ports and how things communicate. And then we're going to touch base on domains and some command line tools. So these are just common things that we normally use when we're dealing with networks. Okay. So once again, as always, I'm going to say this on the front end. Please make sure that you guys look at the glossary at the end of the chapter so you guys will all know some of the terms because we use a lot of acronyms and you see a lot of acronyms on the quizzes. So a couple things with addressing. It's happening at the data link layer of the OSI model. Okay, these are hexadecimal numbers you'll see in some of the PowerPoints and some of the slides that's coming up. 48 bits written as 6 hexadecimal numbers separated by a colon. We're just looking at the MAC address. It's like the MAC address that you will see on a computer. Okay, it's also called the physical address. These two terms are interchangeable. Sometimes in computers say, what's the physical address to that computer, or what's the MAC address to that computer? So those terms are interchangeable. So you may see that on quizzes. You might see some people say physical address, or some people might say what's the MAC address. And it operates at the data link layer of the OSI model. Okay, so the IP address, we have two types of IP address. When we first started out, we started out with IPv4. It was a 32-bit IP address. It's separated four. We went over binary last week. It was 4 decimal points, 4 digits separated by a decimal point, which we call octets in the networking community. And then because of technology and because of we're thinking that we're going to run out of IP addresses, they came up with IPv6, which allows for additional IP addresses because everybody has an iPhone, everybody has a computer now. Everything is a smart technology, and everything that has a computer in it has to have an IP address. So I think in the 32-bit format, it was something like it was a few billion. I can't remember how many billions of IPs that we can accumulate from that number. But I think it's 4.3 billion. Yes, sir. 4.3 billion IP addresses can be addressed from IPv4, but IPv6, and you would think that that's a lot, but like I said, the whole world, everything has to have an IP. So we came up with IPv6. Transport layer, transport layer port numbers, and then application layer, FQDN, frequently qualified domain name, computer names, and host names. These are, fully qualified domain names. These are names of the computer, and this is how computers know how to communicate what they are on the network. Okay, so just going over the IP address, the MAC address. This is an old picture of a wireless card. You typically don't see these too much more in the computers. In the early days when computers first came out, it was an option if you want to have a network card in your computer or not. But now network cards are in the computer, and it just comes standard. So now that they come standard, they're built in. Now, if when you in your book, or you can zoom in on PowerPoint, you see the MAC address here is kind of circled in red. This is the physical address to the card. Just like your home has an address, this is the address to the computer on the network. Okay, so yeah, it's broken up into 2 different segments. The first 24 bits are known as the organization unique identifier. So this is the tells like what company that manufactured this card. So by looking at the first 24 bits, it's going to have a unique code number to Linksys or Comcast or whatever company that makes network cards. The first 24 bits, Then the last 24 bits make up the extension of the identifier, and it's like the serial number for that particular card. So, and the reason why they do this is because they want to make sure that no two network cards on the network have the same identification number. So they came up with that scheme. So a static IP, you probably heard the term of a static IP address. This is something that the network administrator will assign. Last week, we did a little binary counting and numbers, and you guys were playing around making a few static IP addresses in the discussion. That's something that you guys do. Now, as a network administrator, you have so many computers. You have hundreds and hundreds of computers on your network. And if you had to assign all those static IPs, you go crazy. So it's almost impossible to keep up with it because each computer will keep that address for a while. So the industry came up with a thing called DHCP, Dynamic Host Configuration Protocol, which we have a server, a DHCP server, and what it does is it automatically assigns IP addresses to different computers. So TCP/IP computers are assigned IP addresses. They hold on to them for a while. Every time you go on the internet and you go to Yahoo or Facebook or any of these Google sites, you're temporarily leasing out an IP address to your computer to allow you to get on the network to these different sites. So if you have to physically do that every time, you can see how painful and how painstaking slowly it'll be. So we let technology do the work for us. So a couple of things in the book, and I think you're going to see a couple of things in your lab is how to view an IP address on a computer here. You can go to a command prompt, and if you just go on your typical computer, and I think the book um, points that out. But if you just go to your computer and then open up a command prompt on any computer, and then you type IP CONFIG, it's going to give you the IP address of this computer that I'm on here. So as you can see, my personal computer here, there's no connection. I'm all wireless, so there's no media that's connected here. IPv6, this is the IP address, or this is the hexadecimal breakout that it was talking about before. Temporary IP address, okay, it's all broken down to hexadecimal. IPv4, 10.0.0.99, using a subnet mask of 255.255.255.0. Okay, so you guys can play around with that on your own. You guys probably already know about that. So the subnet mask is a unique identifier. What portion of the IP address is on the network? Okay, and then you also have a DNS server, which is responsible for tracking the computer names. Because if I ask you what is the IP address to Google right now, you couldn't tell me. But if I say go to Google's website, you would type in Google or google.com, and then it'll come up. The name Google is associated, the DNS server, it resolves the name of whatever the friendly name that we can remember. Remember, computers only talk in ones and zeros. It talks in numbers. And if you guys had to remember all those numbers, you go crazy. So what it does now is the DNS server, it takes whatever name you get and it resolves that to a particular IP address, and which gets it to the location you want, which makes it easier. Our job's a lot easier. It's a lot easier for us to get on the network and find what we're looking for. So I used the IP config utility just a second ago in that DOS command prompt, and it gave me some information, and then it told me some things about that. So we kind of already did that a little bit there. So IPv4, we're just going to talk about IPv4 just a little bit here. It's a 32-bit address, and it's organized by 4 octets. They're all in 8 bits. They're all 8 bits apiece. So 4 breakdown segments of 4, like right here on the bottom, 72.56.105.12. This is an example of an IPv4 octet. Each of the 4 octets can be any number between 0 and 255. So 0 between 255 can be in each one of these separate octets, and that will make up an IPv4 IP address. Classical addressing. The dividing line between the network and the host portion is determined by the numerical range that the IP address falls into. So, and the IPv4 addressing is divided into 5 classes. So we have a class A, B, C, D, and E. Okay, so if you look on the bottom here, skipping down, 10.000 that's a class A IP. This one here, class B, and then this is the class C IP address. So each class represent approximately how many systems you can get on the network. Okay, so you have a company, and then we do have private IP addresses. Class E is used for research. You guys will never use an IP just research. Educational institutions and researchers and probably government institutions, they use Class C IP addresses. Class D are private IP addresses for private networks. Okay, so the general public uses these. Your company is going to be using these going forward. Okay, so this right here is just talking about the different classes a little bit more and how many computer systems you can get per class. So in a Class A IP address, approximately a possible network, you can divide a Class A up into 126 networks. So if you have a company and you want to divide, so one network could be accounting, one network can be HR, one network can be students, accounts, one network can be email addresses. So basically, whatever, you have 160 possibilities. So you can get out of here mathematically 60 million computers on your network. Okay. In the Class B network, same thing. This is how many networks you can get, 16,000. But then you can only get 65 computers, 65,000 computers on your network. Class C, which is very, very popular. A lot of people use these, a lot of companies use these. You get up to 2 million networks on the Class C network. I'm sorry, you can have approximately 2 million networks, but each network is going to have only about 255 computers, IP addresses on their network. So it's a lot more easier to manage. It's not so big numbers. How many students. So, but they bounce around. They bounce around. But this is just the mathematical breakdown of what you can get for that. So a Class D and a Class E were not available to the general use. Class D. These are the different octets for Class D, used for multicasting when you're doing like streaming and stuff like that or whatever else, and you're broadcasting a lot to lot. Like this Zoom is probably using a Class D type IP addressing scheme. And then Class E, as I said before, is used for research. Okay. 255, 255, used to broadcast messages to TCP in the background. Okay. And then currently assigned. This is kind of how you read what you see right here. Okay. And then you're reading this week, you guys will get more information on that. NAT. So like I said, we talk about a lot of terminology. NAT, network address translation, technique designed to conserve public IP addresses as needed by a private network. So these are little tricks that the network administrator would do. Address translation is a process where a gateway device substitutes the private IP address with its own public address. And this is a little more deeper and get into the woods, but just be familiar with the terms and what they do. The PAT, port address translation, a process assigning a TCP port number to each ongoing session between the local host and the internet. Okay, so look at this example here. This is just talking about port addressing. So this is your internet web server. It's coming into your gateway on a 92.52.44.1. That's your gateway IP address. So the translation is here. So the gateway has everything here, but each one, it looks like it's on a different port. Everything's communicating on a different port. So these IP addresses 20.21.22.23, but they all are using the same gateway IP coming in translating on a different port. Okay, two variations of a NAT can be you should be aware of. You got the SNAT, and then you got the DNAT. Okay, the static or source network address translation. The gateway assigns the same public IP. So it's from here, it's assigning the same public IP to the host each time it makes a request over the internet. So every time somebody's going to the internet, it's going to use the same IP address on the SNAT. It's going to use the same IP address going out this way. So on the DNAT, the gateway has a pool of public IP addresses. So it has a few it can pull from. And so it's probably going to this server here, which is giving up those pool of IP addresses, and it's giving it a different one each time. So I'm not 100% sure why they do that or what's the advantage or disadvantages of that, but that's what they do. IPv6 has been around for a while. I'm gonna put a video up later up in the discussion. We'll probably go over a little IPv6 and IPv4. Right now, they thought we were going to run out of IP addresses and we should only be using IPv6. That's what the theory was going into this. But as you can see, most of the time we're still using IPv4. So, but IPv6 is out there and is very widely used. And it is very widely used. And, so just be aware of it. Okay, because sometimes as a network administrator, when I was working in networks, not really I have to work much about IPv6, but it runs a little differently because we needed more numbers. It's the leading zeros, a four character hex block can be eliminated. So basically, they're telling you this slide here kind of tells you the easiest way to write a number in a 16-bit number in IPv6. So it's saying here because you have these zeros here. So basically, if you have like all zeros, you could eliminate writing it out by using the brackets and the colons. Only one set of double colon is used per IP. So you can just bracket this piece off, put the double colons in here. So it won't be so long drawn out. So right here is two different ways you can write it. The bottom way is probably the best. You can see right here how they colon out, and then they drop the leading zeros here and the C, and then they drop the leading zeros there. Okay, so that truncated this number instead of having. Now this is also correct, but it's not the best way to write it. So, all right, IPv6 terminology links, sometimes called local link. Okay, any land bounded by a router. Okay, that's just some of the terminology. An interface is a node attached to a link. A dual stack when the network is configured to use both the IPv4 and IPv6. And then you have tunneling, a method used by IPv6 to transport IPv6 packets through and over an IPv4 network. Okay, so just different a few things you need to know, be aware of with IPv4 and IPv6. Types of IPv6 addressing is unicast. Specifies a single node on the network, and you got global cast address can be routed over the internet, and then you got local local unicast addressing can be used to communicate with the node in the same link. So, and then this is kind of how that works. We're not going to get deep into this. This is high in the weeds, but just from a high level point of view, this is kind of how unicast and a local link addressing transport their packets. Okay, so once again, this IPv6. We're gonna just kind of, as you read more, you understand it more later. But broadcasting, and then so when it broadcasts, everybody's going to get it. Multicast is going to send it to just certain specific information that want to cast that information to, and any cast, anybody can get it. And then unicast just send it just to one person there. So this is some of the prefixing for when you see an IPv6. I try not to put a lot of IPv6 on the quizzes and stuff like that, but please be aware of it. You might see it in the and Cengage. But the reason why I just want you guys really to be familiar with it. Like I said, this book is a lot more granular and deeper than you really need to. So I'm not going to spend a whole lot of time on it. So auto configuration for IPv6 addressing is designed so that computers can auto configure its own linked local IP address, similar to IPv4 for APIP addressing. So, and then these are some of the step ones. Computer creates an IP address. So it creates one of its own IP addresses. It randomly generates it. Okay, generates it from the network packet on the MAC address. Step 2, the computer checks to make sure that the IP address is unique. Then the computer asks the router or the network to provide configuration information for that. If the router responds with the GHB information, the computer uses whatever information that might be called. Okay, and then process is called prefix discovery. Okay, so you have your port numbers. So we're never going to talk about ports and sockets. Okay, so computers, although they have an IP address, they also have to communicate on a specific port number to ensure. And then what they do is that ensures data is transmitted to the correct process among multiple processing running on the computer. And then you also have sockets, consist of the IP host address and the port number of an application. Okay, so an example of this is how it was written. This is the IP address in the front, and then you have the colon, and then it's separated by, I guess it's port 23, was right here. And port numbers are divided by, they're in 3 types. You have the well-known, then you have restricted ports, and then you also have your private ones. Okay, but when you see this colon on the back, that kind of lets you know what communication port is talking on, and it has to match on the other end, or the systems won't talk. Okay, so when you're when these 2 computers are talking here, they have an IP address, but they have to be talking on the same port. So 2 things have to match: the IP and the port number. Okay, and in the medical industry, we also look for a thing called, we call it the AE title, which is pretty much the name of the system associated with the IP address and the correct port number, so they can communicate on the proper channel. Typical ports not yet covered. So these are just, I think the book goes into this a little further. Lightweight directory access support, server message block. Yeah, so yeah, I've never had to trivial TFTP. I have used trivial file transfer protocol in my career. NTP, I don't think I use any of these other ones, not knowingly directly. But so just FYI, like I say, if you see these acronyms, just kind of be familiar with them. And if anybody out there is thinking about taking the CompTIA examination, remember the acronyms. Okay, domain name and DNS name. So we talked about earlier that the domain name is, well, let's just go through this. Character-based names are easy to remember than IP address. We talked about that earlier. So basically, when you got a fully qualified domain name, that's at the top level. Like I said, Google is associated with an IP address. And then, so if you go to, let's see, let's just try this really quick here. Let's see what Google, I might have to put google.com. Hold on a second. What I do? Up here. Oh, she's not doing anything. What's going on here? All right, so what you see right here is this. Google, we know Google as google.com, but we want to go to the website. But the internet and the computer knows Google name as this IPv6 address right here, which is 2607F8P0:4005:807 which should have been all zeros. We saw that earlier. 000E:. Okay, that is Google's IP address. So the DNS server, when I put in google.com, it says, oh, google.com, let me see what's going on with that. Okay, this is his address. Now let me go over to Google and communicate with Google like that. So that's what the DNS server typically does, because its domain name must be registered within the Internet Naming Authority that works on the behalf of this is some communication organization, ICANN. The ICANN restricts what type of host can be associated with the ARPA, MIL, Internet Education, and Government sites. So this is military, education, government, and I'm not sure what this one stands for. So anyway, this organization is responsible who can have what or whatever else like that. Name resolution is the process of discovering the IP address of the host when they're using a fully qualified domain name. Okay, so here we go. These are some of the domain suffixes right here. So .gov is always going to be a government site. .edu is always education. .com is commercial. ARPA reserved for lookup domains, special internet functions. Okay, that's why I'm not familiar with .org, .net, United States military organization, businesses info. And I think you guys probably seen all these dots at you guys probably all have seen all of them. I know I've probably used every one on here except for maybe the first one and probably one of the military ones. Don't deal with the military too much. DNS is the application layer. That's where it's at on the OSI model, at the application layer. The client server system of computers and database made up of these elements, the namespace, the name server, and the resolution layer. A DNS client that requests information from the DNS name server. Okay, so that's kind of what it does. And like I said, as you read the book, you guys are going to probably pick up a few more tips on that as well. Namespace database. Each organization that provides host services is responsible for providing and maintaining its own DNS authority service for the public access. Okay. So the authoritative servers are the computers, are the servers that for whatever company and their IP address of the computer, the domain. So they're responsible for that. So if your company is doing DNS, your company computer is responsible for that. Okay, four common types of DNS servers. You got the primary, you got the secondary, you got the caching, and you got the forwarding. And the authoritative name server for the organization holds the authority of DNS for the organization as a whole. The secondary DNS server backs up that one. It backs up the first one. The caching one is accesses the public DNS data and caches the DNS information it collects. And the forwarding server receives queries from local clients, but doesn't work to resolve these queries. So any of these servers can coexist on the same machine. So one machine can do, one server can be doing multiple functions. That's basically what this last statement is saying right here. Okay, so the DNS name server are organized in a hierarchical structure. So this, you got the .com, the org, you got the education sites right here. You know, .org, you got Craigslist and PBS. The education, you got a couple of educational sites down here, and then you got your .com down here. So this server at the top level is responsible for maintaining and organizing these names down here. That's what it's saying there. At the root level, 13 clusters of the root server holds information used to locate top level domains. The TDL service holds information about authoritative service owned by various organizations. Okay, clear as mud. Don't worry about it. This is just high level, something that you got. one thing that this class is going to do, and this book does, it goes into levels kind of a lot more deeper than that the engineer would, somebody designing this. So don't fret. If you work in this industry, you don't need to know all this, okay? If you're taking a certification test, you should be aware. You should be aware and understand what's going on. And the reason why I say that is because once you get the job or you pass the test, you know, all you got to do is go to your notes and get the book. But here you're learning for the first time, and it's kind of giving you an information of how things are working. Okay, so this is just, you know, if you look at this whole thing, you got your local client computer here, local DNS server. You know, so I don't know what website. Oh, we're going to www.mdc.edu. So we're going to an educational website. So it's going to go out from the DNS server. It's going to go to the root domain name. It's going to do some information talking back, resolve it, send it back here. Then it's going to go back out to the TDL name server, find the .edu that you were looking for. Okay, I found it. Go back, and then it's going to go back and find. And this is all done in the blink of an eye. I mean, it's done in milliseconds. You saw how fast you can go to Google's website and things of that nature. So it's breaking it down as if a lot is going on, which is a lot is going on. However, it's all happening literally in the blink of an eye. Okay. Name server, ways the resolution process can get more complex. I'm not even going to go into this because I don't want to intimidate you guys in the future. I'll let you guys read the book, and then that's going to let you know how it's going to it does that. So because you guys haven't probably read the chapter yet, so I'm not going to go too deep in here. But what I will say is that these are some of the ways. There are several types of records called resources can be kept. So you got the A for addresses, and then then you got the C name, chronological name records. Okay, you got the PTR pointers. You got the name servers, mail exchange servers. So just be aware. Buyer beware. That's all I'm asking right now. Okay, and I think this continue. DNS service software, Berkeley Internet Name Domain. Okay, most popular DNS service software is open source. It's free. A lot of people like that, especially in the Bay Area. Microsoft DNS Server built the DNS on the Windows platform. Okay, it's more for secure network, and then you got the DMZ or demilitarization zone, areas between your firewall. Okay, so this is kind of where the software works and how it works and where it lives. Okay, so you get the DNS server handles by two different servers so the internet can work. So you got the computers here, you got your firewall, you got this is where you got your external DNS server. Because once it leaves, this is your company, and once it goes to your firewall, you got the external DNS. It's still got to try to resolve that name as it's going through another firewall going out to the internet. So this going to get into a little troubleshooting. Computers they work with you, and work with the computers is very good to if it's broken and you can fix it, then you feel good about yourself. Troubleshooting is always one of my most favorite things to do because it helps you really understand what's going on. Even in the labs, if something goes wrong with the labs, and I will say this, always call Cengage first because you may not get me, and they get some support people on, especially if one of the labs is not functioning properly. And then also notify me as well. And if I try to help out as soon as I can. Event viewer. Every computer has an event viewer. We've always used them. So use your event viewer. It gives you a lot of information. It gives you a lot of information in the event viewer. It helps you understand what was happening at the time and help you troubleshoot. Some other commands that you should always be familiar with. You have the ping command, ipconfig. These are both Windows commands here. Ifconfig gives you the same information as ipconfig, but it's for Linux-based systems. And NS lookup, okay, that's more Windows. You can use for Windows too. And then dig. Dig is the same thing as NS lookup, but it's a Linux base. Be familiar with these. You will use these for the rest of your lives, even if you don't work in computers. Just setting stuff up at your home or configuring stuff at your job, just simple stuff. It gives you a lot of information when you pull these commands up. And so even if you do like a ping command, and if you don't know what to put in after the ping, just do a space question mark or ping question mark. Is that ping question mark? What am I trying to show? There we go. Maybe no question mark. I thought it was at the question mark line. So if you don't know what that command does, when you just do a ping, you hit the button, it tells you all the different switches you can utilize to if you want to look for timeout or record how many hops routes it takes to a hop, and things of that nature. So you could use the question mark command, and the same you could do the same for what was the other one? So if I did an NS lookup on my computer, it's just telling me that my default server is on Comcast. So that's what it was. I thought it was going to give me. This is kind of weird. I want to upgrade. Maybe my number's not working. So, but anyway, these commands are very, very useful, and just be familiarize yourself with them. So, ping, we just talked about that. So ping is installed. Okay, it's from the NIF. It basically is just looking at how many you're trying to just send out packets to see what's connected on the computer. Okay, what's the computer connected to, and if it's going to bounce back like an echo to find out if something is connected or if it's not connected. It's just a low level, entry level communication, first step protocol for communication. Okay. IPv6, what are we talking about here? IPv6 networks use a version of ICMP called ICMP6, ping 6 on Linux computers. Okay, so this is kind of the way it does it on Linux-based computers using IPv6. Okay, I can't test it because I don't have a Linux box with me, and you got to be on IPv6 network. Most things are defaulted for IPv4. Okay, so just that command here, but they gave a screenshot of how it will look. And so once they put the ping, I mean, it's funny, I ping Google, I put ping google.com, and on IPv4, you see how it shows an IP address here, okay? But in the IPv6 network, it showed it in hexadecimal here. You see how it's differently? It displays a little bit differently depending on the network that you're on. Okay, so ipconfig shows the current TCP address of the domain name of what computer you're on. Okay, so I just did that, and then you guys are gonna probably be doing some of that on your lab. There's some stuff that I'm sure a lot of you guys already know how to do and understand. So it also displays the MAC address. You see how the MAC address here? Then that's now, because in the beginning I was saying that each computer has a network card. We don't use the wireless cards anymore. A lot of times computers already have the motherboards have it on, we call it an onboard NIC card. So, but it still has a MAC address, even though you don't have the external card that we use to purchase. All computers come with a Wi-Fi card now. Now, as you know, there's more Wi-Fi than LAN-based cards because most laptops don't even have a place where you can plug in a network cable. Okay, so DHCP, we talked about DHCP servers tonight. This is where the IP address of the DHCP server is, and the domain name server. Okay, this is IP address here, and the domain server is going to be resolving those names to IP addresses. Okay, ifconfig These are, like I said, these are just other Linux. To the same information is displayed that we will get using IP config, IF config, but that's for those Linux-based users and Unix-based users. And that's Unix is one of the mother technologies, early stages of technology. Okay, so and if you run that, this is how it displays. So on IP config, it's kind of, in my opinion, a little bit neater, a little bit easier to understand. But in a Unix-based system, it just displays a little bit. It still see the package, transmit and receive, okay? And then down here, it just tells you the package and how many bytes went and how long and things of that nature. So you get the same information. It just displays slightly different, slightly different. So get into that. NS lookup, um, namespace lookup allows you to query the DNS database of any computer on your network to find the host name or device of a specific IP address, or vice versa. You type in NS lookup. So if you type in NS lookup and IP address, it's going to display the name of whatever that is. So if we'll just do for time's sake, like the Google. So they typed up here NS lookup cengage.com, the name. The server, Google public domain DNS server, that's the address. And then it came back cengage.com, and this is the IP address to Cengage. It came back with that. Okay, and here, let's see, Google, let's see, what is it? NS lookup. They just did NS lookup. The default server is Google public DNS minus a google.com. So inactive mode on it. So this is interactive mode. I'm not exactly sure. I gotta test that out to see. Okay, you can change the DNS server from within interactive mode of the server sub command of a specific IP address. So you can all do this in your command prompt. To exit NS lookup, just type exit, and then it'll take you out. But here, this is what they were doing before, and it resolved the name here. The server subcommand can be used to change the DNS server. So if you want to change the DNS server from here, and if you want to put a different address in there, and I've never had to do this. These are full-time network admins. They're doing this. Well, that's probably in their early configuration stages, but I've never had to do this. So on a Linux command, same type of functionality, but they, we can't leave Linux out, those Linux guys. So they use a dig command, domain information groper, and this kind of information that it gives. Same type of information that the DNS server provides from Linux, okay? Time. Now, I can't say stresses enough. A lot of people have issues with their systems, and you'd be surprised when the time is off. If a system is on a network, and if the system is on a network with a domain server or a server, the times have to sync. If the times don't sync, you can have a lot of problems. And in troubleshooting, I work in the medical industry in the IT field, and twice a year, I would have to go to 52 different hospitals, all my accounts, and double check, because time is so critical, even in surgery, because I work in surgery, that when the doctor administered a medication, a drug, it has to be time stamped when it was administered. And if the times don't sync, and if they're not syncing with the server and things like that, it can cause all kind of problems legally, but also the system won't work properly. So always double check the time. W32 time will give you time, and then you can do a couple of command prompts. Usually systems, big network companies have a time sync server. They have one server dedicated on their network to sync the time. And when you set up a brand new network configuration, you want to set that server to whatever organization is, and you set the time. And all computer systems on that network, say if it's a big say if it's Apple or Yahoo or just a grocery store chain. But if all the computers there, the time has to sync. If you have the wrong time zone, or even if it's off by 2 or 3 minutes, you can have weird problems with your system and your software. I've seen it, and it is a problem. DHCP issues. If you are getting DHCP errors on multiple clients, are having trouble connecting to the network, check the settings in your DHCP server. Make sure the DHCP scope of language enough to account for the number of clients that it's trying to support. Yeah, you want to make sure that you don't have it's trying to, it has more servers trying to get to it than it can support. Because this DHCP server, its whole job is to assign out IP addresses. So you want to make sure that you have it configured properly. And personally, I've never had that issue, so I don't think you would have that issue. But if you are a network administrator and you're installing all these computers at Solano College, you want to be aware of that. Network connection configuration issues, incorrect net mask, gateway, and duplicate IP addresses. The computers are smart. You can put an IP address in the system, and if it's a duplicate, it will reject it. It's saying IP address is already configured on the network. It'll tell you, error come up. Now, this is the key. If the system is turned off, so say if you are doing a brand new network and you are signing out static IP addresses, you're not using a DHCP server, and you forget where you left off, or you fat finger something, and you give it a duplicate IP address, and say hypothetically speaking, you did some today, and then and you turn those systems off, and then tomorrow you do a few more, and then the systems may not be on at the same time. And so you get these calls, hey, intermittently, hey, I keep getting this message pop up every so often that I get a duplicate IP address, or I'm getting kicked off the network. And then that kind of lets you know, okay, now I got to find out where that computer is. Okay. And there are different tricks of the trade when you go to figure it out. But if you have a computer that turns off and on, and it's not on all the time, but if it's on all the time, it's easier. But if they turn it off, you do a few things to find it. So you want to make sure that all that. So you just basically just paying attention, writing things down, and making sure everything is connected properly. Okay, and that is chapter 3. I will stop the recording and